Hello everybody, welcome once again to our continuation of the studies of the singular numerical relativity, which is the completion of general relativity. Today we are going to study the second chapter, which is about the 5 physical operations of numbers. In classic mathematics, we know that there are only 4 operations we call the 4 fundamental operations that we can apply to numbers. But from today, we will learn that there is another possibility for us to make use of numbers efficiently by applying physical operations to the numbers. The reason we can do so is that numbers are real. Numbers are substantial. Therefore, they are part of the creation and they make the fabric of the cosmos we call space-time. They are the building blocks of space-time. And being the building block of the space-time, numbers can help us to learn about the basic structure of the distribution of energy in the universe, because numbers themselves produce energy. You have learned already that information is energy, and we use numbers in order to express the information. This is the reason why numbers have energy in them. So today we are going to learn about how we can use exactly numbers in order to make them productive. I would like to give you a simple analogy between a gold miner and a mathematician. A gold miner will dig his gold. Of course, he gets something like this. You see, this is the raw gold. And he will sell. At what price? He may sell at $10,000 per kilo. But he will sell to the gold bar maker. This gold bar maker will transform the gold into bars, as you see. Then he sells at a higher price, $32,000. So he makes more money because he knows how to transform the gold. But still, even he's not making enough money yet, because there is still a jewelry maker who can buy this gold bar and transform it into jewelries. It means he knows how to cut into small pieces the gold and make things that he can sell, and he will make more money. In mathematics, of course, when we use numbers, as we see here, 5 equal 5, we are just like this gold miner. Of course, here you can apply the 4 fundamental operations, and you graduate, you become a professor of mathematics, whatever. You can become an accountant. You use all this, the businessmen use these 4 fundamental operations to make money. So you can be great with this. However, this level is not really the level what we need. We need instead to make use of numbers in a more precious way. We can make this by using numbers in form of a binary system. So we use the binary system, we transform 5 into digits, and then we make more. With that, we have created already this information technologies that we have. But still, even though we have achieved a lot until now, we are requested to go higher, because number 5 is not just 5. 5 means 5 plus 4 plus 3 plus 2 plus 1. So if we know how to deal with this, then we will be better, because here we will have what we call the universal cubic system that will be provided. When we say qubit system, of course there are already scientists who are working on quantum computers that use qubits. But in order for them to be successful, they need this universal qubit system in order to produce many bits of information. They need this. That's why we are advising that you have to learn how to use the numbers this way. So today we will learn about the physical operations, and the 5 physical operations are deceleration, acceleration, expansion, projection, and explosion. It means a number can be accelerated, a number can be decelerated, a number can be expanded, a number can be projected, and a number can be exploded. These are things that you don't have idea about, because how can a number really be exploded, for example? How we are going to do that? But it is very simple, because numbers have a structure, and this structure will allow us to make all these operations work. So in these operations, we can do it in 1 dimension, 2 dimensions, or 3 dimensions. To begin with, we start with the deceleration of a number. To decelerate a number, you have simply to count the number downward. It means you count the number going down by reducing 1, meaning you by minusing 1, -1, -2, -3. So you go down to 0. For example, if our number is 5 here, you count the number 4, 3, 2, 1, 0. Why we have to reach to 0? Because we make 5 steps. You count the number as many times as the number itself. Therefore, we have to make 1 step, 2, 3, 4, and 5. So the last you will always get here is 0, because it will be 5 minus 5, n minus n. Then now we can calculate the whole value. And this is something we did already when we were calculating the relative value of a number. So you sum up all the values here. 5 plus 4 plus 3 plus 2 plus 1 plus 0. So you have all of these give you 15. How to get that? To get that true formula, you have to get 5 times 5 plus 1 divided by 2. 5 times 5 plus 1 divided by 2. And this is n times n plus 1 divided by 2. This is the deceleration of a number. So you apply for any number except 0. We don't allow 0. 0 means nothing in physics, as we will learn it maybe soon. So only everything begins with number 1. So now we go to the next operation. The next operation is the acceleration. To accelerate a number is to count it upwards. We count upwards. It means you have n here. Now you go plus 1, plus 2, plus 3, plus 4, plus 5, and etc. until you reach to that number which is n. An example is this. If we have to accelerate number 5, we just count it upward as many times as 5. It means we are going to make 5 steps, just as we did for the deceleration. So we go by adding 1, 1, 1, 1. As you see the values come here, we have 6, 7, 8, 9, 10. And the last number there is 10 times, the 10 here is 5 times 2. That's a 2n. Now, we have to calculate it and see how we can formulate this. We sum up all the values and we see that the total is 45. 45 is 15 times 3. It means deceleration of 5 times 3. So every time the deceleration is 3 times less than the acceleration. Acceleration is 3 times more than the deceleration, in other terms. So we applied the formula of the deceleration here, because the deceleration of 5 is 5 times 5 plus 1 divided by 2. Then we have to multiply that by 3. That's what gives us the 45 here. As a formula, of course, the acceleration will be n times n plus 1 divided by 2 multiplied by 3. It's very simple as that. All you have to know that if you get the deceleration, for example, the deceleration is 9. For you to get the acceleration, you have to multiply that by 3. So it will be 27. That's strictly like that. For all the numbers, you get the answer. Next, we will see about the expansion of a number. To expand a number, expansion means you have to go on both sides, up and down. So we have to count it upwards and downwards. We have n here. On one hand, it is plus 1, plus 2 plus 3, and on the other hand is minus 1, minus 2, minus 3, going down to 0. And here it's going up to 2n. So we have an example, 5. When we expand 5, we count it on both sides. Then we have here is 0 and there is 10. Now to formulate this, of course you have to sum up all these numbers. But how to do the formulation of that? The formulation is that you have to consider that, as we have seen already above with the deceleration, it seems we are decelerating number 10. So we need only to calculate the deceleration of number 10 in order for us to have the answer. Of course, when we do it in a very conventional way, like kindergarten students, so there we see we get 0 plus 1 plus 2 plus 3 plus 4 plus, and it gives us 55. But now, as maybe grown-up people, we have to formulate this. We are like calculating the deceleration of 10. Therefore, the deceleration of 10 is 10 times 10 plus 1 divided by 2. And if we replace now the value of 10 by 2 times 5, then we have 2 times 5 multiplied by 2 times 5 plus 1 divided by 2. Then when we do our operation here, we cancel this and this. Then what remains is that 55 equal 5 times 2 times 5 plus 1 divided, no more division, sorry. So what we have here is only 5 times 2 times 5 plus 1. That's what gives us n times 2n plus 1. That's the expansion of a number. Next operation is the projection. And here we are going to see the projection, because the projection actually, the projection and the upcoming, which is the explosion, they are the one only that can go up to the 3 dimensions. The one we have seen, the previous ones, which are deceleration, acceleration, and expansion, there, of course, they work just in 1 dimension. But here, we will have the projection in 1 dimension, 2 dimensions, and 3 dimensions. The same will happen for the explosion. So let's see how this idea works. First, we have to go back to the bricks, because we started everything with observing the bricks. We observe the brick, and we see here we have the bricks as we demonstrated before, that this brick cannot be here without the support of all these bricks. So this brick is in superposition to other bricks. And in physics, we do understand that because of the force of gravity, there is this force. This has a mass, is not it? and it is exercising a force on all of these bricks, and this force will go through all these bricks below. So it starts there, it expands to the 2, to the 3, to the 4, and to the 5 before it will reach the floor. And we say that the value of the brick depends on its location. So when it is here, this brick will go 4 times. Of course, as we designed it here, is this brick goes 4 times, and to reach the floor, it means, physically speaking, we see this brick putting pressure on all the bricks below it. Then when it reaches the floor, it will be in 5 locations. And to do that, we have to get the value of this brick, which is n plus 1. That's what will help us to know about the location, the number of locations here. So we are concerned about the locations because we talk about particles in physics, that the particles can be in many places at the same time. And here you see a transparency of somehow the double slit experiment working here. We see that as the particle goes, of course, it is getting more, it is occupying more and more space. And this is actually how light works, as we are going to explain it above. So we are concerned about the number of locations. Not only the particles can be in many places at the same time, but even the bricks can be in many locations at the same time. This is what it means. Then, now we can know the numerical value of the brick, so the physical numerical value of the brick. So if we have this, again, we repeat, of course, when we consider the order of the rows, all these bricks should be 1. Row number 1, so meaning they have all the same value because they are on the row number 1. That's in our conventional way of thinking. This should be 2, 3, 4, then this should be 5. But here we are dealing with physics. In physics, when bricks are scattered on the floor, we did not put them in superpositions on top of each other, then these bricks, they have all the same value. But once we put them in superposition on one another, then in this case, the values of the brick begin to change. The value of the brick will depend on its location. Now, we say that these bricks here on the floor, they are actually 0. Why? Because they don't have any bricks below them. So their value is 0. But the bricks on the second row here, they will have the value of 1. The third row, 2. The fourth row, 3. the fifth row 4. Therefore, the numerical value of the brick depends on the row. Of course, we should call the location, but this location, now it is minus 1. It means it's supposed to be here 1, but it becomes 0. Supposed to be 2, become 1. Okay? And etc. as you see. So now, the point is that this brick is touching the floor with all of these bricks. Then, because it does that, the order of propagation of the projection will change. The brick here becomes the level 0 itself. Then this becomes level 1, level 2, level 3, level 4, and no more. Level no more. So why we say, what we want to emphasize here is that you cannot project all the bricks of level 0 of row 1, or whose the value are 0. Why? Because they have no bricks below them. Therefore, the value on the viewpoint of the physics, the value is 0. So 0 means nothing. You have nothing when you have 0. Nothing. Therefore, 0 cannot be used in our operations as a master number. We call master number the base. It cannot be a base. You cannot do any calculation based on 0. You have to have at least 1. And the 1 here can be any size. The size of 1 can be the whole universe. It can be a star. It can be the earth. Can be the moon. Can be a table. So the size can be any. The size of 1. Therefore, do not request 0 point something. No, please. Here we will not deal with all those 0 points. If you want, you reduce your unit. That's it. Until you get 1, 2, 3, 4. You have to reduce your unit to 1, 2, 3. Here we are talking only about units. The unit can be any. 1 centimeter, 1 millimeter, nanometer. Everything is unit. Can be 10 kilometers. It's a unit. So, unit has no precise size. So we can do, that's why n, 1 is anything. Can be anything. So, at this point, now, we do understand how the projection works. So the projection goes from level 0 to level 1, level 2, level 3, level 4, etc. Goes like that. So now let's see it in one dimension, how it works. In one dimension, if you have a number here, this is a number 4, as we have seen above, then we project it. It will go and touch. So if you are having a projection, of course, you have a starting, a source of the light that goes to touch. And we see the light goes occupying more and more space. That's what we have seen, that you start with 1 brick, 2, 3, 4, 5. So the last we get there in 1 dimension indicates the number of locations. And here, the number of locations is the number plus 1 in 1 dimension projection. It means n plus 1. Then we can do also the projection in 2 dimensions. In 2 dimensions, we have to expand the number on 90 degrees. So we do the expansion on 90 degrees. And when you do the expansion, it means on one side, it decelerates, and the other side is accelerated. So here we see this. Here we decelerate, and here we accelerate. Now, in this case, as you see, 4 must go 4 steps here and 4 steps here. Therefore, these numbers on this side, these are the numbers we called the minimum values, the minimum prime values. And here are the numbers we called before as the maximum. Therefore, here, these numbers, they have a relationship because 5 and 3 are on the same level. 2 and 6 are on the same level. 1, 7 on the same level, and 0 and 8 are on the same level. And these numbers must communicate because we have to fill up all these vacant space. And this is the reason why we need the 90 degrees. We need the 90 degrees because of the number of vacant space here. We see the number of locations in this vacant space. And you will see it that for us, for number 3 to communicate with number 5, as I explained before, they must pass through 4. So there must be a 4 there. And that will continue here. For 2 to communicate with 6, we need to pass with through 3, 4, 5. Here 1, 7, pass through 2, 3, 4, 5, 6. And here 0, 8 must pass through 1, 2, 3, 4, 5, 6, 7. So now we have our complete data for number 4. As you see, we can now make some kind of analysis here. We are doing some kind of analysis. We find out that here we have only 1 value. On the second, we have 3 values. Here, 5, 7, 9. And the number of values is increasing by 2 because of the 2 dimensions. We are talking about the 2 dimension. Therefore, the increase is by 2, 2, 2. If for 1 dimension, the increase was by 1, 1, 1. That's the law. And we can consider now, again, how many values up to that, up to a certain level. You see here, 1 value only. Of course, it will remain 1 location. On the first level, we have 3. Then up to this level, we have to sum up all of this. So we consider from level 0 to level 1, and that gives us 4 locations. If we go here, we will add also the 5. Then it will give us 9. We add the 7, gives us 16. We add the 9, it gives us 25 locations. As a whole, now we have 25 locations. To calculate that, we need to get 4 plus 1 squared. 25 is equal to 4 plus 1 squared. It's very simple as that. Then, now let's do some analysis here to see how really these values work. We have to see now in another form, another dimension, because we saw already that we can make it by making like a pyramid in the previous. Now we are going to try to study it in applying this law. We said that we need 90 degrees. The 90 degrees goes as this, because we are adding. We have 1 value, then the next will be 3 values. Next, 5 values. Next, this is a 7, and next is 9. So the graphic you see here as a whole is the same that we have now changed. We just changed the angle. Before we did it directly under 4. Now we put it in a 90 degrees so that you can see exactly how the 90 degrees works. Because there is a law that we are going to discover here that numbers follow. As you see, these are known in mathematics as odd numbers. These are odd numbers. 1, 3, 5, 7, 9. Everybody knows about this. It's very simple. Then, by adding each time an odd number, we make a squared number. Squared number. So here, of course, we start with 1. 1 is already squared. 1 squared is 1. Then for us to go to the next square, we have to add 3. Next square, we have 5. Next square, we have 7. The next 9. If we can continue going, for us to have the 6 square, we have to add 11. 25 plus 11, 36, is not it? Correct. So what we are trying to show here is that numbers obey what we call the square law. Numbers obey the square law. You see, as we go we start with 1 location. Then in the projection, because we are talking about the projection of a number, in the projection, when you go to the second level, you form again another square. So we are adding what we call the square arrow. The square arrow gives us what we call the information zone about the level or the whole number. Here it is the whole number, 4, but per level, as we go here, we have 2 squared, 3 squared, level 2, level 3, and level 4. So level 4 is the maximum. That's why it gives us what we call the information zone. So these numbers, as I have said here, these numbers indicate the number of values per level, representing the different square arrows. So we have different square arrows per level. A square arrow, you see this is an arrow. It's going like that. Do you see that? So we add an arrow. So the square arrow, what is a square arrow in reality? It's the value that you add to a squared number to get the next squared number. That's simple as that. We go from 1 squared, then to get the next, which is 2 squared, we have to add 3. So this value here is called the square arrow. These are simple things that you know already, but here now we are giving a different, maybe the terminology that is coming in, talking about the square. But these are very simple things for students in even in elementary. They can understand this. Very simple. So the next here, you see, these numbers represent the number of value up to the level, as I explained. So it means you go from, this is the first level, then when you add the square arrow of level 1, then you have 2 squared. Square arrow of level 2, you have 3 squared. This is the total you get here, the total as a whole. Therefore, we just calculate them this way. These numbers are calculated by simply having the level number times 2 plus 1. Level number times 2 plus 1, 2n. This level number is expressed as a small letter. I already said in the previous chapter, we already said that. That's the level number. Then the bigger letter, and here also we have for the information up to a level number, the information zone of a level is, you get small n plus 1 squared. This is the information zone of, and so if you want to know, for example, this here up to the green here, how to get this information zone. The information zone, it means the number of locations. That's what we call information zone. The total number of locations up to that level is this. We see. So you have to get the level, which is the level number here is 2 times, times 2, then plus 1. That's the number of on this level. Then if you want to know the information zone, you have to get the this level number, which is 2 plus 1 squared. 2 plus 1 is 3 squared. Yeah, 3 squared. You do the same for these are actually the things that we will need most. These small details you see here, they are very significant. We will need them for having our information analysis. Because we are going to make what we call the ID card of a number. Because every number has an ID. Therefore, these values, all these values we are calculating here, must appear on that card. So all the values will be recorded on just one piece. We call a card of a number. The information card of a number. So let's go to the next. We have been talking about the information zone of a number. Here is number 4. Number 4 will make steps 1, 2, 3, 4 to reach to its destination. And we have already calculated that by doing this, we have to take 4 plus 1 squared. So it means we have 25 locations it will be. This is something that was very difficult for me to really come up with it, because it was something that you cannot really figure out easily. But the day I found out about this, really a great miracle happened. That I saw the universe as a whole become very small. And it says there that now you can see very far. You see that you have only 1 here. Then already there you have 25. It means these 25 locations become your vision capacity. So you can see now with 25. Number 4 can use these 25 locations in order to fulfill a task. So the number 4 represents or symbolizes the singularity of number 4. Because to do this thing, number 4 in reality cannot be in 25 locations. It is not practical. That's true. That's the truth. But 4 will use its singularity in order to be in this location. So, because every number has a singularity, and that singularity is a bigger number. That's what, so 4 need to take a value which is very big in order for it to be there, and that value is what we call the singularity of number 4. So it is not exactly 4 which will be here, which will occupy. It is impossible. 4, no. 4 is helping us only to know how the singularity can occupy all this. And this is the symbol of the event horizon. This is the symbol of that. So here you have the singularity, and here you have the surface of the black hole. That's why here we are going to unite or unify the information from the surface of the black hole and the singularity. So we will build a connection here. Let's move to the next. Now we will talk about the explosion of a number. A number can explode. This is an explosion. If you have a ball of light, like the sun is a ball of light, it gives light, or it radiates in all directions, 300 degrees. 360 degrees, sorry. 360 degrees. So you have here like this, and to get really to this how we will make the mapping of our data, the number will be in the middle and we will explode it. Then through the explosion there will be what we call expansion. So we will need an expansion in 8 directions. That's why you see on one side there are 4 2 ends, and on the other side 4 2 zeros. So we'll be accelerating, decelerating, decelerating and accelerating on the other side. This is how we are going to achieve that. Let's see how it works. We have number 4. Number 4 will explode. This is the first level. So here it goes plus 1, plus 1, plus 1, minus 1, minus 1, minus 1. Here we have these values. So now we have to consider the number of locations, because that's what is important to us. The number of locations, you will observe well that in the first level explosion, number 4 will be in 8 locations. Then to the second level, if you count this, of course the numbers now are going, as you see, plus 1, minus 1. Then we go here, if you count this in green, all for the second level, we have 16. 16. Remember those numbers. 8 here for the first level, 16 for the second level. The third level, if you count them, they will be 24. This is already a picture that I think if you are good in mathematics, you don't need to be so good, actually, because these are very simple things. I said already here, first level 8, second level 16. What are we doing? Multiplying only by the level number. So 8 times the level number. And here we have 24. The next level will be, if you have a very good head, you will know that this will be times 4. 8 times 4, which is 32. So you have these values. This is what I have been talking about. We have 8, 16, 24, 32. Then to calculate for any level, just get the number of locations will be 8 times the level number, and that's what you get. 8 times the level number. It's very simple. Then now, what we are doing is that when we do an explosion at a certain level, we are making always a square around another square. We are forming a square of different level. You see this is originally 1. Then when we add this 8, we make again another, now another square. And here we have for the following next square, and next square. So what we are doing here, we are adding what we call the envelope. Square envelope. This is the square envelope. Envelope here we call it. In 2 dimensions, we talked about the square arrow. But in this explosion, we talk about the square envelope because it is 360 degrees explosion. You understand? So that's what we are learning. So we are learning about the number of locations that a number can occupy. Now we have gone higher because with the projection we had only 25 locations. Now we have gone up to 81. So number 4 can still be in 81 locations. Oh my God. This is big. Because when we will get numbers like 10, you will be amazed how much you will get. Because the formula actually is coming up. Here is the formula. So number 4 explodes, then it will occupy 81 locations. And to calculate that, you have to get 2 times 4 plus 1 squared. 2n plus 1 squared. Simple as that. That's how we have maximized our use of number 4. So from now on, we can have number 4 can give us 81 possibilities. So if you really work on the relativistic nature of number 4, then you will produce 81 values here that number 4 can use. That's huge. In terms of information, that's very big, because what we will be here is something that can solve so many problems. So many problems will be solved. So imagine with number 4, you can do this calculation of 81 different values. That's great. With one number, 4. What about other numbers? 1 million. I don't touch. So I'm saying that the vibration of a number follows the square law. The vibration of a number obeys the square law. And even the explosion of a number obeys the square law. So numbers in general obey the square law. That's why you see they go 1 square, 2 square, 3 square, advancing. Of course, in an explosion, we will have 1 square, 3 square, 5 square. We say follow the odd numbers. Odd numbers, odd values. So you will see 9 square, 11 square. You will never have something like 10 square, no, in an explosion. 10, the even numbers are not included. But that's bigger, because as you see, we went from 25 to now 81 locations. So that's very important for us to say. Now, the last point here, we are going to explain a little bit what is the location of a number. We have this controversy going on in physics about what you call the many worlds. Many worlds is so much misinterpreted. Everett, who came up with this idea, he had a very good feeling about this. And I think he never intended it to be expressing something like many worlds, meaning many earths or many universes as we call them today, the multiverse. No, that was not the thing. It's not about this. That's why I say location is different from earth or world. Instead, we have to understand it as a earth. It's very amazing. Huh? This word and that one, just the difference is H. Earth and earth. So we have to understand it as a earth. Earth is a place of fire, a location of fire, a field of energy. It means every particle. Particle means anything. A human being, a dog, a stone, the planet Earth, the moon, the stars there, all, each one of us as a particle, we occupy a certain space wherever we are. That space, that location is what we call the world. In the many world expression, this is my world. For example, I set up my stage here. You cannot just come and disturb me because this is my world. You understand what it means? Very simple as that. A street dancer, you see those acrobatic dancers in the street, what they do? They go in a public place, then they just go put something, stone here, and then create their own space. Then you cannot just come in because you will be violating his space. And that space there becomes his world. That's his world. So the world here is a field of energy. It means a place where all my energy can, I'm radiating some kind of force where I am. And this force I have, it's moving everything around me. So I have a certain area of responsibility, my area of responsibility. That's what you call a location. That's what we could call a world. So the world is not this world here you see like this, big earth or the universe. No, it's not about that. We don't need other universes for us to solve our problems in our universe. Our universe has all the tools. Even our sins are forgiven on earth. Yes or not? So you are not bringing your sins to another place, to another planet. No, you must find a solution here on earth. We cannot go and solve our problems using other universes. Instead, our universe has everything we need. Space-time is there for every solution we need. Actually, that's what I mean. Space-time is there. Therefore, the field of space-time, the field of energy is there. for any solution we want. Therefore, we are going to solve our problems here on Earth. This actually is the end of this chapter, chapter 2, which has been all about the five physical operations of numbers. You understand? So you have seen about the acceleration, the deceleration, the expansion, the explosion, and the projection. So we have seen all of that. These happen for numbers. And what is important for us, we have learned today, is the number of locations that a particle can occupy. When we are talking about number here, see number as a particle. See number as an object. The number of locations is n plus 1 squared. Very important. Number plus 1 squared. The number of particles, the number of locations we need. Thank you very much for following today, and we will have again in the next chapter we will be discussing now about the 3-dimension explosion and projection. Thank you very much.